Now, we're talking about pressure, right? And pressure is a force divided by an area. So think about what we've been talking about so far. Like, how can I affect the pressure, right? Well, one way is to increase temperature. If temperature goes up, right, then that increases pressure. Opposite's also true. If I decrease the temperature, that should decrease the pressure. Now, that's assuming the container stays the same size, right? If I make it bigger, then what happens? Well, if I made the container bigger, then the volume is changing. That means the surface area is changing, and that also has an effect. So we'll talk about these sort of things independently, assuming everything else stays the same, at least initially. So I can increase the force by increasing the temperature. I can also increase the area by making it bigger, right? So if I make the container bigger, or if I increase the volume, what that'll cause to happen is it'll cause the area to increase. Now, as long as you're not changing the number of molecules that are in there, right, then what'll happen is those molecules don't collide as frequently, and as a result, there's less force and a larger area, total force and a larger area at the same time. So this top part goes down and this bottom part goes up, and so what ends up happening when you increase the volume is you decrease pressure. Now, another sort of just side note, like if you're thinking about pressure and what it means, right? When you stand on your feet all day, your feet get tired, right? That's because your weight exerts a force, and your feet are the area of your feet is what you're feeling the force of. So if you have small feet, you actually feel more force than if you have large feet. And it's actually really possible for a large person with large feet to have less pressure on their feet than a small person with really small feet. Very likely it's actually about the same, but in essence, it is possible for those things to go counterintuitive. Like you would think like a really small person it would be easy on their feet. But if they are in fact have really tiny feet, they would be feeling a lot of pressure. Again, tiny feet means what? Small area, and that causes the pressure to increase. There's all kinds of units that we use for measuring pressure. Perhaps the most common unit, the one that people think about a lot, is actually atmospheres. But originally, the way pressure was measured, it was measured using what's called a Mercury Barometer, and it was measured in millimeters of mercury. So let me explain these to you because that's sort of the origin, and then we'll talk about what it means to be millimeters of mercury, or what we hear from like the newspaper, like the fishing report and all that kind of stuff. Typically in the United States, that's reported in inches. Okay. So the way a barometer would work is they would take a barrel of mercury, okay, and they would stick a long glass tube in it. Now this glass tube was sealed on one end, so they would fill it up like this. All right, they would take this tube and they would stick it in the mercury and they would let it fill all the way to the top, and they would actually stick their finger on it and pull it out, and there'd be a dish like this, and it would have mercury in it as well, so Hg. And I don't know if you know this, but mercury is super toxic. Now, when they stick the mercury in here, or the glass tube in here, what would happen is it would start out like this, and the mercury would be all the way to the top. Okay, so this is initially. And then what would happen is right away, not with much delay, as soon as they let their finger off, this mercury would settle down like this, and there would be a level of mercury on the inside of the tube. Now, this tube's sealed, so there's no way for anything to get up here. So there's actually just a vacuum up here. And the mercury would fall until the pressure on the outside right, was equal to the pressure exerted by the mercury trying to get out. So this would balance. So think about what happens if the pressure on the outside would go up, right? That means it was pushing down harder. This mercury would rise up higher. If the pressure on the outside was low, then it would drop down and the mercury would be lower. Okay, so these types of pressure units, right, when they were measured in millimeters, and so we would call this, right, millimeters of mercury. It is literally how high the mercury column is against the liquid on the outside, liquid mercury on the outside. Typically, when we're like under normal conditions, like probably about like now, that mercury column would be 760 millimeters of mercury high. And so we get this idea that 1 atmosphere is equal to 760 millimeters of mercury. It turns out if you do the unit conversion, like 760 millimeters, right? And then 10 millimeters per centimeter, and then 2.54 centimeters is 1 inch. This comes out to 29.92, right, inches. So in the weather report, when you hear inches of mercury, or sometimes you hear millimeters of mercury, but when you're hearing inches of mercury, it's actually just how tall the column of mercury is measured in inches instead of in centimeters or millimeters, okay? Other real common units of pressure are PSI. So if you were measuring the PSI versus atmospheres, it turns out 1 atmosphere is equal to 14.7 pounds per inch squared. That's the SI part, squared inches, right? And the most common SI unit for pressure is known as a Pascal. And we also know that 1 atmosphere is 101,325 pascals. So having said that, there's a lot of different kind of pressure units. You'll be expected to be able to convert between the pressure units using given conversion factors. Now, one other thing before we move on and do some like conversion practice is that there's something known as standard temperature and pressure and in gas laws, or when we're talking about gases. And the standard temperature and pressure are 1 atmosphere and 0 degrees Celsius. So that's like the freezing point of water, right? These are numbers I expect you to remember. I'll ask you like what's standard temperature and pressure. You have to be careful because it turns out when you look up like standard temperature and pressure, there's like a military standard temperature and pressure. There's all kinds of standard temperatures and pressures. Best thing to do is just remember that 1 and 0, and then it's pretty straightforward. Okay, so let's say your tire pressure is 35 psi, and we want to calculate pascals and atmospheres pressure for that tire pressure. So we'll go in pascals. We'll do pascals first. It's 35 psi, and then there's something that we do a lot in chemistry with pressure units. We'll just simply make some easy substitutions. So, for example, I know that 1 atmosphere, right, is 101,325 pascals, but I also know that it's 14 psi as well. So what I'll do is I'll just simply combine those two. Since they're equal to each other, I'll say 14.7 psi. It's much easier to do, by the way, if you just write it out like that rather than trying to write the fractional unit. For every 101,325 pascals. So then you can just pull up your calculator and calculate that value. So 35 times 101,325 divided by 14.7, and that ends up being 241,000 pascals. So 2, 4, 1, let's see, what was that? 2, 5, 0. Because the PSI will cancel. And then two significant figures, so that's right here. So we would say 2.4, and then you got to go 1, 2, 3, 4, 5 times 10 to the 5th pascals. Like that. Now, if you're going to do the same conversion to atmospheres, it's a little bit easier because in ATM, right, it's going to be 35 psi. And then it's 14.7 psi for every 1 ATM. So no fancy tricks done on that one. So it's 35 divided by 14.7, and that'll give you 2.38. So 2.38 atmospheres, and rounded to 2 sig figs, it's 2.4 ATM. Okay, so those actually all represent the same pressure. But again, when it's a straight conversion to atmospheres, it's relatively easy. It's also pretty easy if you're converting between unusual pressure units, because you know what equals. Typically, you know what equals 1 atmosphere. So you just use that as your conversion factor. You just make a relationship that way.